the Magna IO project within the Ethereum Foundation. So today, I'd like to talk about how cryptography, or you will learn in this core program, will expand the power of smart contracts. So smart contracts are programs executed on the blockchain, such as Ethereum. And I believe this is similar to the law of physics, because it's similar to in the sense that physical laws cannot be modified or stopped or reversed. Smart contracts on an ideal blockchain will not be able to will not be modified, stopped, and also reverted. However, today's pure smart contracts has a lot of limitations. So in similar to a brain in an aquarium, smart contracts can only read and modify the state data on the Ethereum, on the blockchain, and this state data is completely available to anyone. So can we expand such enforcement of the smart contracts to wider areas? And I believe we can do that by using cryptography. So I have been, from this perspective, I have been researching blockchain protocols and many security technologies, especially cryptography. And my core research question has been first, how can cryptography expand the power of enforcement power of these smart contracts, and how can we use such power to build useful application of blockchains? And for example, in ZK email, which is a ZK project I co-founded in 2022, this allows smart contracts to verify contents of the emails directly using our ZKP, zero knowledge proof. So we can say this ZK email as eyes to read emails to smart contracts. And our IO or MPC, cryptographic techniques schemes are called MPC or IO, will allow smart contracts to hide hide their state data from any kind of human. So we can say smart contracts will be able to have some kind of secret memories which is hidden from any humans. So today I like to talk about especially about ZKP, MPC, and the IO, because these cryptographic techniques has been used or will be used in the future for many of the blockchain applications. So these technologies have different trade-offs among the functionality, range of the functionality, minimum trust models, and practicality. So especially regarding functionalities, while ZKP can only handle our secret data held by single prover, our MPC and IO can mix multiple parties secret data in the same computation. Regarding the trust model, MPC requires continuously running on the honest majority of the committees, some committees, which is a kind of party of the kind of group of the trusted, some group of trusted parties. However, ZKP and IO requires only this honest majority or majority of the committees. In particular, as long as one party of the committee is honest, that's fine. And also, such assumption is required only during the setup phase. So today, concretely, I'd like to explain how each of the cryptographic schemes will help smart contracts based on my experiences. So first, I'll talk about ZK email, or a project using ZKP for emails. So in general, this is difficult for smart contracts to verify off-chain data because, as I said, smart contracts does not have direct access to the such data outside the blockchain. So many of the traditional approaches rely on like some attesters such as like MPC committees or some or trusted hardwares and so on. But of course, this also like adds like a new trust assumption in the such intermediate attester, which is not like a desirable. So, however, or if the such off-chain data is sent via emails, our ZK email will enable smart contracts to verify these off-chain data only with the minimum additional trust assumption. And then in particular, our user can make some proof of the ZK proof of the user's email, and the smart contracts can directly verify such proofs as a part of the on-chain like a smart contract program. And in high level, when you send emails, or your emails is actually already are signed by the email domain servers such as Gmail, and according to the DKIM protocol. So the ZK email leverages this like a DKIM protocol, and it proves that your email is like something like real. I mean, like your email is like actually sent by the correct owner of the from email address by verifying this like a email signature, assuming that only this like email domain server such as Gmail does not like force the fake email. And also, this can only like this can pass the email data and selectively or disclose the email contents. So, for example, you can only review the from email address or some part of the subject or part of the email body. In more detail, ZKP circuit to verify our emails consists of these like three components: RSA verification component, or hash-2 component, and the regix verification component. And these two components verify that your email header is actually signed by the correct email domain server. And also, this regix verification component verifies that your email header satisfies some like a predefined regix of the string, such as like your subject satisfies some like a predefined regix definition, depending on the like type of the like email data. And also, this can expose substring of the email by finding the substring which satisfies some like a specific regix. And using this by using this ZK email for on-chain applications, for example, we built email wallet. So this email wallet allows users to send tokens to any email address simply by sending emails. So in more detail, each user can like each email user can make the wallet built by the smart contracts, and then a user can transfer tokens in their email wallet to any kind of like a email address or like a Ethereum address, or simply by sending email with a like message like send one is to bob@gmail.com. Then the corresponding token will be automatically transferred into the wallet corresponding to the recipient email address. As an example application is the email account recovery. So, as you know, even if you lose your password for your bank account or some like PayPal or like any kind of Web2 services, you can easily reset your password through your email account. Similarly, our email account recovery allows like recovering your contract wallet, or simply by sending some emails, even when you use our private key to control your wallet. So our email account recovery was integrated into the wallet called Clave Wallet, or which is a wallet service in Turkey. And for example, So for example, so when you try to like recover your wallet, when you lose the private key, or the email address you set as the email guardian will receive an email like this one. Then they just need to like reply to this email with a message confirm. And then this like email recipient will receive the confirmation email, and on our server, the recovery like a wallet recovery process will be performed automatically. And you can see that like this is very easy for the email guardian to like support help this like a recovery process. So like you can like even set like your family's like email address or your friend's address who is not in the clipped field as the email guardian of your clipped wallet. And we generalize such like applications as a SDK called Email TX Builder. So like anyone can make such applications easily just by writing some solidity contracts. And in this SDK, the email address in the from field will be automatically transformed into the corresponding Ethereum address. And also some like a message either in the subject or in the email body will be also disclosed to the smart contract provided for the smart contract as a command. Sorry? Fine. Okay. So so in this sense, like smart contract can like so we abstract the like we like bridge the such email sender information and some command in the email or to the like corresponding Ethereum address and their command string which can be accessed by the smart contract, solidity contract. And internally, when user actually sends such an email to a permissionless server called Layer, and the Layer will generate the ZK proof of the given sent user's email, and the transfer and the send and then make a transaction to provide this proof for the smart contract. Then smart contract can do any kind of operation according to the given like email sender's corresponding Ethereum address and the provided command. And in some emails for this like our ZK email, this kind of like a hex string called account code is contained. And this account code helps the privacy protection and the decentralization of the layers. So actually, the Ethereum address provided for the smart contract is defined as a hash of the email address and this account code. So that and this account code is revealed only to the like each like a user, email user, and a layer, so that like this makes our email address private, like hidden from the on-chain information. And also, our ZKP circuit for this email text builder verifies that this account code is contained in the user's email. So this implies so if the to make such proofs, layer is forced to contains account code, or a user need to like contain account code or in their email, so that this prevents a malicious layer from withholding the account code. And finally, this like our availability process, confirmation process, will like allows layers decentralization, because even if your current layer, for example, even if your current layer goes offline, you can easily switch to the new layer just by sharing the account code with like any kind of new layer. Or since the layer implementation is open source, you can also build your own layer locally. And even if you switch the layer, you don't need to change the like any of the contract address, because as long as you use the same account code, you can always derive the same Ethereum address from your email address and account code. So as a conclusion about ZK email, or ZK email allows smart contracts to read data contents into emails, only assuming that existing email servers such as Gmail will not post the user's email and will not make any kind of proof signatures for the incorrect emails. And this will make our email into a transform email into a new interface for interacting with a smart contract. So so this is a part of the ZK email. So do you have any questions? Do you have any questions?
Sounds wonderful. I don't know. Sounds wonderful. My question is, what if a user loses reveal his email account password? Suppose you got my Gmail account, and then can you steal my, let's say, info?
Okay. Thank you for your question. So this question is what happened if the user for example, I understand my understanding is what happened if the user's email account itself is hacked by, for example, when a user's email account password such as Gmail account password is revealed. And yeah, this depends on the application. So for example, in the case of email wallet, I think this means yeah, adversely can potentially withdraw all of the all of the your funds in your email wallet, because this only the only way to verify if this is a correct transfer request is in this email wallet is to verify that this email user actually sends email. So if adversely can send any kind of emails on behalf of your email address, this is basically this is the same situation as a case in which your private key of your email address is hacked. And for this account recovery, this one has some protection mechanisms even when email account is hacked. So specifically in this Play Wallet example, so even when a email account user request account recovery process, it has some a time lock period, and during this period, a wallet owner can cancel this recovery process if the wallet owner still has the access to the a private key of the wallet. So in other words, unless both the email guardian account and the users wallet account users account private key of the user's wallet are lost, either email guardian or wallet owner can protect and recover your wallet in this example, in this email account recovery. Does it make sense? Thank you. Does anyone have any more questions? Yeah.
How do you find the email address? Is that fine or you transfer?
Okay. Yeah, thank you for your question. So her question is, how can we bind the a relation between the email address and the Ethereum address? And the first point is that this a relation is not unique. So if you use other account code, you can make a multiple Ethereum address from the same email address. So this does not say each address is unique to the email address. And but this is fine in most cases. So for example, in the case of email wallet, or you don't have like a, for example, so this means you can make multiple Ethereum address or contract wallets from the same email address for email wallet. But this is basically, this doesn't make any issue, and the adversary basically wants to like kind of hack the like a email wallet which already has some like funds, but and in this case like they need to get the account code. They need to get both the private key of the Gmail and the account code. So like so I mean. So this ensures that if you have account code, like you can also if you have both the email account like your Gmail account or email account in general, and plus your account code, you can keep accessing to the same like Ethereum address, such as same email wallet. But this does not prevent you from making a new Ethereum address from the same email address. Does it make sense?
So there is a email you already have. You have the one address that you get it. And you also you can find multiple addresses into one email.
Yes.
If you want to send one, for example, you want to send one Ether to Alice, then you just need to send the email and tell the contract that I want to use a address to send how much Ether to someone. You just need to set it and then confirm it, and you can essentially start.
Basically, like a user can just like switch the multiple addresses from this with using the same email address. However, like there's no mechanisms to like kind of rig the like a multiple Ethereum addresses which are derived from the same email address, and this is because basically for privacy reasons, and also so I think in the current implementation of this like an email wallet or email like account company, the layer only assumes that like one email user uses only one account code, but like in the like a circuit level or solidity contract level, like a user can switch the like multiple Ethereum address by switching which account code they want to use. So like a more technically like our zk circuit also like receives account code as a part of the private input, so that by changing which kind of account code they like a prover layer provides, they can like make for example, they can make proof of the email on behalf of the Ethereum address derived from account code A, and if they make proof by using the account code B and the user's email address, same email address, they can make the proof of the email on behalf of the Ethereum address corresponding to account code B.
So if you use the email to send the Bitcoin Ethereum to someone to make a transaction, you don't need to know this address private city, and you can get the transaction stuff.
Yeah, so like basically you should keep access. You should maintain access to the account code, but usually you don't need to put account code always, because like in the standard case, this layer also holds the account code, because account code is not like a private key in the sense that even if you only have account code, no one can withdraw your like fundings from your email wallet, because this also requires like a signature by like a Gmail, like email domain servers. So like this layer server stores account code, and even if you send emails without account code, this layer will automatically like put the stored account code into the when they make the zk proof. And although we don't have like a mechanisms to switch between multiple accounts, theoretically it is possible that layer changes like which kind of account code will be used even for the same email address, and this makes the zk proof on behalf of the like a different ESLM addresses, even for the same email address.
Why not? This, for example, there is an address that has 50 is already this address, and then can you just not to send this 15 address without using this email address?
So can you repeat the last bit?
There is an address that is already
Maybe.
I'll clarify my understanding. That there is an address that have already binding with the email, and there is 15 is either in this address, and now this user wants to send 15 ether to someone. Does he need to use the email to send the money, or he can just make the transaction just use the private website?
So if user has like multiple is in like multiple accounts, in the case of email wallet, basically in the current implementation, like a user need to make like separate 3 emails because each like a proof of email only assumes like a 1 account code. So like also like each is will be like a kind of managed separately for each like a different account code because ESLM address for this contract wallet is defined for each pair of the email address and account code. So if you have like a 3 account codes for the same email address, you will have 3 contract wallets. And for example, if each of your contract wallet have only like a 5 is of like a 5 is, you can send at most 5 is from like each of the 1 like account code, and then to send 15 is from each of these 3 wallets, you have to send like 3 emails, and you have to make 3 groups with different account codes. Thank you. So, does anyone have any question from like a online side? Fine. Okay. Thank you. Okay, then. Let me check that. Okay. So the question is like, how is the knowledge property used in this ZK node? So basically, like one point is that, so when we derive the like a Ethereum address, so actually like we don't reduce the email address or account code when we make the ZK proof. We only reduce the hash of the Ethereum to control. And typically, like we derive the Ethereum address from the hash of this data, and this hash is be reviewed publicly. So like so hash to Ethereum address is performed publicly on smart contract, but the process to get this hash from email address and account code is performed privately within the ZK group. And we use this account code. So like a user's email like contains like such text for the account code. It's not this one itself. It's not an Ethereum account. It's like it's like you can think this is a kind of like a viewing key. So like even if you have this account code, you cannot spend like funds like from your email wallet because you also need to have like a signature for your email. But if you have this account code, you can like, for example, if you know the account code of my email address, you can compute the Ethereum address of email wallet corresponding to my like email. So you can see the balance of my email. But unless like if you don't have such code, you cannot like find the mapping from the email address to the Ethereum. So it's only for privacy protection reason, and this is why it's fine to like it's fine to store account code in the layers database.
Suppose I get account code, but I cannot withdraw.
Yeah, exactly. Because this also like requires that like ZK proof also requires that there's always a signature for the email header such that the from field in the header is my email address, but you cannot make such signature unless you have the private key of the Gmail server. Yeah, okay. Thank you for your question. Okay, I next go to the second and third part. So our, as I explained, our DKP is very like a practical and requires very minimum trust model. But this cannot mix multiple parties like a secret data. And we can do that by using our either MPC or IO. And in the case, our MPC for blockchain applications, like MPC is usually like employed or with like a delegated model. So in this model, apart from users, there are like some trusted delegated committee parties, and users will like send or encrypted inputs and some like a latest encryption of the latest state to these delegated committees for each kind of computation. And committees will do some computation using MPC and decrypt the output and return the plain text output and the encryption of the new state, updated state. And regarding the security of the committee, if at least like a T out of N parties are like remains honest and online, they can complete this process, and no intermediate private data, including the inputs, will be like revealed. And this model is used for in these cases. So like many users involves the same computation, or the computation is essentially set for, or like some users can be offline during the MPC. And actually, indeed, like this is the case of the smart contracts. So like using MPC, like we can consider like a privacy preserving version of the smart contract. In short, private smart contract. So smart contracts, at least in Ethereum, or smart contract can be seen as some state for computation model, such that the current state is updated according to the input in the user's transaction and some predefined program. And in the private smart contract, I assume the current state or this input and the new state and any intermediate data during the computations are completely encrypted and are hidden from any human. However, programs remains public so that people can verify that like this computation is some it's designed honestly. And since the state data is like encrypted, we can, for example, store some private key or that no one knows in the encrypted state. And using this, like we can, after one note is that like I also assume or the smart contract can publicly output some like a log as events. So like if you know Solidity, or you can think this is a kind of events, like events kind of functions. And since the smart contracts are private, since the program of the private smart contract can access to the private key in the encrypted state, this can, for example, make some signature or like some encryption using the key and output them as a part of the event. So to implement such private smart contract, the committee parties can execute the operations in this gray box using the MPC. So like maybe this seems to be very complex, and I don't explain the detail, but the point is that like this MPC process will first verify that our encryption of the input and the current state are actually recorded on the blockchain. And if this is true, they will decrypt this data using some like a private key, which is like a shared shared, like separated and shared amongst the committee, and do some computation, application specific computation, and this like updated state returned by this computation C will be encrypted by the public key, and this outputs like a log of the application specific log here, and also this encryption of the new state data. And this new state data is recorded onto the blockchain again and used in the next execution of this private smart contract. So one example of the such private example application of the private smart contract is private vaulting. So each of the users like sends the encryption of their vaultings to the private smart contract. And private smart contract can decrypt this during the execution, and will store the, for example, the total point for each candidate, and also like the memo. So also like a private smart contract memorize that Alice already voted, Bob already voted, and so on, to prevent them from like from voting twice. And finally, this private smart contract only outputs the candidate who got the like highest point. And the example is a private matching. So this is a protocol which keeps each participant's private data provided by each participant, and outputting only the optimal like some matching result from computed from this private data. And I think this has a lot of like concrete applications depending on the like combination of these matchings. So like it's not restricted to, it's not only like matchings between individuals, but also like matchings for companies for their businesses, transactions, or like country times countries for some like very like a sensitive like a critical applications. And interestingly, such kind of like a matching outcome result is like a useful information, regardless of whether this is recorded on chain or like off chain. So like this is a unique point because I think most of the smart contract application today assumes that like a data is valuable if and only if this is recorded on chain. So for example, like a balance of your ETH balance is like valuable when this is recorded on the honest like Ethereum blockchain. But if this is like a outside blockchain, like this information is just like a random like integers, and this is useless. But for this matching result, like such information is useful, like regardless of the place this information is recorded. So like I think like this can like this can increase the like new types of the users who are like not necessarily like interested in like our cryptocurrencies now. So in this way, like by using our MPC, we can make private smart contract, and this allows like smart contracts to handle private data, to accumulate and compute private data provided by our various users. However, there is a limitation, which is a trade-off between the safety and liveness. So like a safety means, so we can say safety is high if we have high probability that non-private data is like maliciously reviewed during the MPC. And then we can say we have high liveness if when MPC will eventually like succeed and ends and output some like a computation result. And in this like a MPC, or in most of the MPC, all of the MPC constructions are MPC can like succeed, or if at least T out of N parties like collaborates, and this threshold indicates like a trade-off between safety and liveness. So for example, when the threshold is like highest, which is the same as the number of the path is n, then we can obtain maximum safety because like this can prevent adversely from revealing some like intermediate private data, as long as at least one party is honest. However, this has like a lowest liveness, because if at least one party is not online, it goes offline, then like no one, like an MPC cannot like output the plain text of the computation result. In contrast, if the threshold is just one, we can get maximum liveness and minimum safety. And unfortunately, like we cannot like just select like one of the highest maximum safety or liveness in the case of MPC, because as I said, MPC are continuously relied on such committees, because committee finally need to like collaborate after the competition, each of the competition. So finally, I explained like how IO can overcome this like limitation. So IO is a kind of like a program compiler. So like when you have like a program C, you can generate the function equivalent or program C or tilde. And since this has the same functionality, this obfuscated circuit C tilde will return the same output as the original circuit. And also anyone can evaluate this like a runs this like obfuscated programs on arbitrary input, non-interactively, as long as they can access to the obfuscated circuit. So this means as long as like this obfuscator like broadcast deploys the obfuscated circuit through the internet, then this party can be offline, and because like this like people can use this obfuscated circuit without help from like this obfuscator. However, informally, no one can learn secret or like values or function within this obfuscated circuit. So yeah, this is not correct, but intuitively we can say this like obfuscated circuit behaves as the black box of the like a program. So we can even put the like a private key of the like a Bitcoin or Ethereum. And however, in blockchain applications, like we don't need to like hide all of the like functions, because we also want to like verify how this program works. And in many cases, we just want to hide some private keys hard-coded within the obfuscated circuit. And also, we cannot rely on such, even if like this party just need to do some like a setup process. We don't want to assume that like this party does not reveal the private information later, which is hard-coded in this circuit, in this program. So in practice, I think for blockchain use cases, we can use distributed like obfuscation process. And here, like we can take we can like we can set the threshold to be the like n, or so we can get the maximum safety, because like as I said, people don't need to like continuously rely on these like parties, or after the setup process outcomes this like obfuscated circuit. So in this case, like IO can fix the trade-off by like removing the interaction between obfuscated like a trusted party, committee, and users after the setup process, and so that like they can just get the highest safety. And formally, like there are two definitions of IO, and so like actually like IO is the security of IO is like somehow like a different weaker than like a pure black box definition, but like even for the stronger definition, and there are like a trade-off between the like security definition and the required trust model. But even for the like a stronger security definition, we only need like a heuristic, but like a acceptable like a trust model. So I think maybe like other researchers have different opinions, but I believe like we can accept this like a trust model, and we can like in most cases we can just assume this IO as a black box in practice, and we can use IO to make private smart contract in the similar way as like an MPC case. So instead of like this intermediate process is same as a MPC case, but instead of performing this process through the MPC, we can make the program circuit which performs this like a gray box processes, and we can obfuscate this program. So after that, anyone can like access to this program without knowing the like a hard-coded private key and so on. And so like so you may think like this IO is like a perfect solution, but this is still, but the biggest problem is that IO is not yet like a practical cryptographic schemes, and there are like many approaches, and this is why like we are researching practical construction of this IO in Machina IoT project, and our contribution is that like in the existing approaches, like most of them depends on the cryptographic scheme called functional encryption, and this like requires very huge computational overhead due to the like kind of recursive encryption process. So like we propose a new method which avoids this recursive process and replace this with simple matrix operations. And we built the implementation. So although we have the implementation still have some limitation, this implementation demonstrates like our most like not most like innovative path of the construction. And this is a benchmark of our current IO implementation. So this is very funny. So because this input size means like input size of the program are being obfuscated. So this does not mean the size of the obfuscate, the size of the program. This means supported input size of the program. But even for the program with 4 input bit, like obfuscation takes like 307, more than 300 minutes, and the obfuscated size, it becomes like memory size becomes more than around like 300 gigabytes, and the obfuscated circuit size becomes like I think around like 60 gigabytes. However, evaluation time seems to be still like a practical, or not. I don't say this is like a practical compared to ZKP, but this is still like a realistic time, probably. Yeah, but we definitely need to improve the efficiency more from the theoretical perspective, and we are researching more like new optimization techniques. And our technical milestone is to increase the input size up to the around 100 kilobytes. And if we can achieve that, we can use like well-known techniques to like delegate most of the our process in the obfuscated circuit into the FU3 plus ZKP. So like finally, I think by combining all of the cryptographic techniques we know, we will be able to obtain the practical IO. So this is like links to our works. So ZK is here, and the Machina IO is my current project to work on the practical I/O construction. Okay, thank you for listening. Do you have any question?
Great presentation. My question is about benchmark. You mentioned there are two IOs, that is efficiency of application and ideal of application. So my question is benchmark you show is which of them
Okay.
is efficient or ideal?
Thank you for the question. So the question is that so which scheme which scheme our client implementation supports? And the answer is that implementation is more process with an indistinguishable specification. However, our client implementation only supports this one indistinguishable representation only for some slow down function, such that the output of the function, all of the output of the function should be some slow down value. But we can extend this to the indistinguishable representation for any target, but just by additionally computing the hash of the input, and also we can extend this left construction into the right construction by using the hash plus some public key encryption. So so the conclusion is that our implementation is more weaker restricted primitive than this indistinguishable representation. But I hope we can finally extend this to the ideal representation just by additionally computing some hash functions. Does anyone have question, maybe from online site? Or if people want to problem like the question is that if people want to program the I/O black box, will it be similar to writing circuits and the connect with I/O backend, or it will be more like writing general purpose programming language? So I see. So I think in early stage, yeah, I also think so. People will write some circuits through the DSL, is similar to the current a ZKP circuits with SAGAM and so on. But I think once we have practical I/O construction, it will not take a lot of time to support more like a VM implementation to support more kind of general purpose programs, such as programs written in C, Rust, and so on. And this is because so if we can achieve this technical milestone, we only need to use I/O for ZK verification and FEG decryption, and we can do the main computation, application-specific computation within FEG. So if we have practical FEG VM and if we have practical I/O only for FEG decryption plus ZK verification, we can immediately obtain I/O for a VM. Does it make sense? Okay, yeah, thank you. So does anyone have any more question? Okay. Yeah.
Really catch up with you at any point. One thing I wanted to reply is that trend that how IO
Okay, so the question is that how completely I/O can improve the our MPC approaches. So in short, I think I can say like a so in MPC users continuously need to write on these committees because so users continuously need to write on these delegated committees because to obtain the output of the plain text this process depends on some secret keys or secret shares held by each MPC committees. In contrast, if we have IO, we only need to we no longer need to interact with anyone to obtain the output of some multi-party computation as long as they already have access to the RC. And so I think from so you want more kind of answer from practical perspective, right? From a application side or a technical side. Applications, yeah. So in application side, I can say, for example, when you want to make some okay, so for example, when you want to make some Bitcoin bridge, you usually need to assume some committees because the only way to make our signature of the signature for the Bitcoin transaction is to write on let these committees hold the share of the secret Bitcoin private keys. So that first if you want to build such applications, you first need to prepare such committees and continuously upload such kind of committee for this until the this application ends. And also from user perspective, users always need to trust that more than threshold number of the parties works honestly and remains online during the service. In contrast, when you want to build such applications using IO, you just need to complete the initial process, the setup process. So you can see this regarding this traffic setup. So do you know traffic setup from the TTP? Yeah. So in the current ZKP, we sometimes are conduct a trusted setup ceremony such that random people can join some kind of setuping process, and if at least one party is honest, then generated proving key and verifying key of the ZKP will be secure. So similarly, when you want to make new application using this obfuscate circuit, you just need to conduct such trusted setup ceremony, and you just need to collect a random people, and you just need to believe that at least one party was honest during this setup phase. And after that, you don't need to upload any kind of trusted parties, and users don't need to trust anyone after the setup.
IO as a solution for the setup of engine. Just a setup solution. Is that correct?
IO is a setup. So sorry, can you repeat the last part?
CK is a setup processing, and the IO is just a solution for setup.
I think IO is not a solution for setup because IO still requires setup. But IO is a solution for removing the a trust assumption after the setup. So this solves the problem after the setup, and this only puts the assumption in the during the setup. Yeah, it's also true. So actually, if we obfuscate the circuit, if we obfuscate some obfuscated universal circuit, we can also say we can reuse the same obfuscate circuit for various circuits applications.
Then there is a solution for the universal setup. Then why you say there is some problem
So like a universal setup is, I think it's only for ZKP settings, right? Yeah. So like a ZKP setup is only for generating proving key and verifying key of the ZKP scheme. But this IO can embed any kind of functions, any kind of private data as a part of the program, and you can make the like any kind of black box for any programs. So like this is more kind of universal. Yeah, thank you. Okay, maybe it's time. So yeah, if you have any question, like please feel free to ask the questions on like a Discord or like a email and so on. Okay, thank you for listening.